Hello everyone and welcome to class of Ethernet as a WAN technology. In this class today, we are going to discuss about Ethernet as WAN technology. In previous times, Ethernet was only appropriate for LAN, but IEEE approved some Ethernet standards in ways that it made Ethernet a reasonable WAN technology. So Ethernet as a WAN. 1000 base LX standard which uses single mode fiber cabling with the support for a 5 kilometer cable length. 1000 base ZX standard it supports an even longer 70 kilometer cable length. IEEE approved cabling distances for fiber Ethernet links. Ethernet become a reasonable WAN technology. WAN service providers offers WAN services that take full advantage of Ethernet. Service providers offer a wide variety of these WAN services with many different names. The customer connects to an Ethernet link using a router interface. Instead of a telco switch, service provider uses an Ethernet switch. The Ethernet link leaves the customer building and connects to some of the service provider location, which is called as POP, point of presence. Inside the service provider's network, the service provider uses any technology that it wants to create the specific WAN services. Ethernet WANs that create a layer 2 service. Ethernet WAN service includes a wide variety of specific services that vary in ways that change how routers use those services. We have Ethernet WAN, E-line, Ethernet emulation and EOMPLS. Ethernet WAN, which is a generic name to differentiate it from Ethernet LAN. Then we have E-line, which is Ethernet line service. It is a term from the Metro Ethernet Forum, which is MEF, for the kind of point-to-point Ethernet WAN service shown. Ethernet emulation, a term which emphasizes that link is not a literal Ethernet link from end to end. EOMPLS, a term that refers to multi-protocol level switching, a technology that can be used to create the Ethernet service for the customer. IP routing. IP focuses on the job of routing data in the form of IP packets from the source to the destination host. Both IPv4 and IPv6 defines the same kind of network layer product functions but with different details. IP focuses on the job of routing data in the form of IP packets from source to destination host. IP concerns with logical details rather than physical details of delivering data. IP doesn't concern itself with the physical transmission of data. Instead, it relies on lower TCP/IP layers to do the physical transmission of data. The network layer specifies how packets travel end-to-end over TCP/IP network even when the packet crosses many different types of LANs and the WAN links. Here, the IP addressing rules help to make IP routing much more efficient by grouping addresses into subnets. Then we have network layer routing or forwarding load. Here, we have routers and end user computers which are host. They both work together and perform IP routing. Hosts use that software to choose where to send IP packets, often to a nearby routers. These routers make choice of where to send IP packets to the next or not. Together with the host and routers, they deliver the IP packet to the correct destination. This is a process from PC1, R1, R2 and R3 and then PC2. PC1. Destination is in another group, sent to nearby router. Then IP packet is sent to R1. This says my route says send to router R2. So IP packet is transferred to R2. R2 says send to R3. Then IP packet transfers to I3. Here R3 says my route says send directly to PC2. So IP packet is forward to the PC2. Then we have host forwarding logic. That means sending the packet to the default router. PC1 does some basic analysis and then chooses to send the IP packet to router so that the router will forward the packet. PC1 analyzes the destination address and realizes that PC2 address is not the same LAN as PC1. So PC1 logic tells it to send the packet to a device whose job is to know where to route data. So a nearby router on the same LAN, which is called as PC1 default router. To send the IP packet to the default router, the sender sends a data link frame across a medium to the nearby router. This frame includes the packet in the data portion of the frame. That frame uses the layer 2 addressing in the data link header to ensure that the nearby router receives that frame. Then we have R1 and R2 logic. That means routing data across the network. All routers use the same general process to route the packet. Each router keeps an IP routing table. This table lists IP addresses grouping, which is known as IP networks or IP subnets. When a router receives a packet, it compares the packet destination address with the entries in all the routing table and makes a match. This matching entry also lists directions that tells that router where to forward the packet. So R1 would have matched the destination address to the routing table entry, which in turn told the R1 to send the packet to R2 in our previous example. Similarly, R2 would have matched and told the R2 to send the R3. The router looks at the IP routing table and directs each packet over the correct next LAN or the WAN link. Then comes the R3 logic. R3 needs to forward the packet directly to PC2, not to other router. So, how the network layer routing uses the LAN and the WANs. While the network layer routing logic ignores the physical transmission details, the bits still have to be transmitted. The network layer logic in a host or a router must hand off the packet to the data link layer protocols, which in turn asks the physical layer to actually send the data. This routing process forwards the network layer packet from end to end through the network, while each data link frame only takes a smaller portion or part of the trip. So each successive DLL frames moves the packet to the next device. That thing about the network layer logic. What are the steps? We require to use data link frame check sequence field to ensure that the frame has no errors. If errors occur, discard the frame. We require to assume that the frame was not discarded at step 1. Discard the old data link header and the table, leaving the packet. Then compare the packet destination address field to the routing table and find the route. This route identifies the outgoing interface and the next hop router addresses. This is how it takes place. Thank you.